Introductory Algebra. So this is just an overview of some algebra problems. So basically we are just looking at solving for x in this course. That's probably the extent of the algebra that we're going to encounter. So just a basic overview here. We're going to go ahead and get started. So when we solve for x, we try to combine like terms on the same side of the equation. So we have x plus 3 is equal to negative 12. So because there's a 3 on this side of the equation and there's a 12 on this side of the equation, we want to try to combine these so that they are both on the same side of the equation. And it should be on the opposite side of the equation that the x is on, because we want to isolate the x. We want x to stand all by itself. So the logical thing to do in this problem is to move the 3 over to the minus 12. So x plus 3 is on this side, so we would have to subtract it away from the x. So if we want to move it to the other side of the equation, we have to do the opposite function. So we would go minus 3 from this side and minus 3 from this side. Anything we do to one side, we have to do to the other side. So now we have eliminated 3 on this side, and we have combined the 3 on this side. Now when we combine minus 12 minus 3, we get minus 15. X minus 15. So that's what x is equal to. Sorry, kind of scrunched in that equal sign there. So x is equal to minus 15, or negative 15. So looking at this next problem, I'd like you to pause the video and try to work through the rest of the ones on this slide, and then you can unpause and I'll go through and work on them with you. Okay, so we have the x here. We want x to be all by itself on this side. We have an 8 that we want to move over to this side to get it away from the x. So we have minus 8 on this side, so to get rid of the 8, we have to add 8, plus 8. So minus 8 plus 8 eliminates the 8 on this side. Whatever we do to one side, we have to do to the other. So we're going to do plus 8. So x equals 19 plus 8, so that gives us 27. I always like to double check my numbers on the calculator. Once you've been working in a laboratory, and if you make a calculation mistake, it stays with you forever, and you just learn to double check everything and triple check your answers. So even though you can do the math in your head, it's always good to follow it up on the calculator to make sure. So in this instance, x is equal to 27. For this one, we have 5 times x. Now with multiplying, we have to divide it away. So if we have 5 times something, we would divide away the 5 part. So to isolate the x, we divide away the 5, and that gets rid of the 5 on that side. Anything we do to that side, we have to do over here, so we're going to divide away the 5 on this side. X equals 40 divided by 5, which is 8. 40 divided by 5, 8. Here we have another example. We have x on this side now. We want to isolate the x. To isolate x, we're going to divide away the thing that's attached to it. So we're going to divide it by 12 on this side to eliminate the 12. Anything we do over here, we have to do over here. X equals 3. And you can go ahead and do in your calculator 36 divided by 12 to confirm, yep, it's 3. So here we're combining addition or subtraction with multiplication. So I'm going to go through the first one, and then you guys can pause the video and go through the next ones. So the first one, 9x minus 5 equals 13. So the first thing we have to do is get all of the decimal numbers to one side of the equation. So we're going to move this over to this side of the equation. In order to do that, we have minus 5. We're going to add 5 to this side, and that eliminates the 5 here. So because we added 5 here, we have to add 5 here. So that becomes 9x equals 18. And we want to, again, double check. 13 plus 5 in our calculator is equal to 18. Now to isolate the x, we do the second step of dividing away the 9. So that cancels that out. Divided by 9 gives us 2. And we double check our calculator. X equals 2. Go ahead and pause the video, and then we'll come back and work through these. Okay, so here we go. Another problem, we have the x attached to the 3 here, but then we have this decimal number. So we want to get all the decimal numbers to one side of the equation to combine like terms. So we have plus 12. Well, we have to minus away the 12. Subtract away the 12 on this side. We can cancel that out. So because we subtracted away the 12 over here, we're going to do the same thing on this side of the equation. So now we rewrite the equation. We have 3x equals 24 minus 12 is 12. And double check that on your calculator. To isolate the x and keep x on one side, we're going to divide away the 3 because that eliminates 3 on that side. Because we divided it on this side, we're also going to divide it over here, divided by 3. So now we get x equals 12 divided by 3. X is equal to 4. Go ahead and check that on your calculator. Now this one over here, we have the x on this side. We're going to move the decimal number over so that x can be isolated. So we have minus 3, so we're going to add 3 to this side to cancel that out, which means we're going to add 3 to this side. 102 plus 3 is 105, is equal to 5x. Now to isolate away the x, we're just going to divide away the 5 that's attached to it and divide it by 5 over here. So 105 divided by 5, 21. X equals 21. All right, so now we've got some multiplication problems going on both sides of the equation. So when you see this parentheses here, that means it's multiplying by that x. So we're going to combine the terms that we can together first. Sorry for flipping that forward here. So this becomes 182x and equals 12 times 2 is 24. So we've just combined those together. Now in order to isolate the x, we're going to want to keep x all by itself. We can divide away by 182 on both sides. So 24 divided by 182 is equal to 0.131868 blah, 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 blah. So we're just going to round this to 0.13. So x is equal to 0.13. So similar thing over here, we're going to try to combine the multiplications together. So we have 45 times 9 to give us 405. And we're going to set that equal to 102x. Now we have 102x over here. To isolate the x and keep x by itself, we're going to have to divide away what's attached to it, 102. So that eliminates that. Anything we do over there has to be done over here. So 405 divided by 102 gives us 3.97. And for this last one on this page, combine the terms together. So we have 17x equals 40 times 2, 80. We want to isolate the x, divide away the 17 that's attached to it, divided by 17. 80 divided by 17 equals 4.7. All right, so now we've got a lot going on both sides of the equation. We have both addition and multiplication happening on both sides of the equation. For this one, we want to combine like terms again. So you can decide which side you want the x's on and which sides you want the decimal on. But the decimals have to go to one side, the x's have to go to another. When I make these decisions, I like to keep x as a positive number. So I see an 8 and a 5. To combine these together, I can either subtract the 8 from the 5 or subtract the 5 from the 8. And like I said, I like to keep these as actual positive numbers. So I'm deciding to move the x's to the left and then move the decimal numbers to the right. So first of all, to move something from one side of the equation to the other, you have to do the opposite function of what's listed. So because I have plus 5x here, I would subtract 5x from this side to eliminate it on that side, and subtract 5x here to bring it over to this side. So 8x minus 5x gives us 3x. So now if we rewrite this, 3x minus 2 equals 4. Well, as I mentioned earlier, I want to move this 2 over so that the decimal numbers are on one side and the x's are on another. So minus 2 is on this side, so we add 2 to this side to get rid of it. And we have to add 2 to this side. So that becomes 3x plus 6, or sorry, 3x equals 6. There we go. 3x equals a positive 6. So now to keep x on this side and to isolate it, we're going to divide away the 3. 6 divided by 3 is 2. So x is equal to 2. Go ahead and pause the video and try to work through the next couple problems. All right, here we go. So I'm going to move the 2x over to this side. So because it's plus 2x, I'm going to minus 2x from both sides. So 3x minus 2x is just 1x. So I can just write 1x, or I can just write x because there's just one of them. So x plus 7 equals 17. Now I want to get rid of this 7 over here so that x is all by itself. So it's plus 7, so I have to minus 7 from here to get rid of it. And because I did that here, I have to do it to the other side, minus 7. 17 minus 7 is 10, so we have x equals 10. Now here is another problem where we didn't talk about this yet, but anytime you have a number on the outside of parentheses, you actually have to carry it in by multiplying it to every portion of the inside of the parentheses. So when we start off first, we're going to do 2 times 3, which gives us 6x, plus the 2 times the 4, which gives us 8. And we're going to set that equal to x plus 6. So I want to move my x's over to this side. So minus x minus x. 6x minus 1x is 5x. So when we rewrite this, we got 5x plus 8 is equal to 6. Now I want to get rid of this 8 here so that x can slowly start to become by itself. So it's plus 8, we do minus 8. That cancels it out over here. 6 minus 8 is negative 2. So now we have 5x is equal to negative 2. So now we're going to divide away the 5 because we want x by itself. That eliminates 5 from that side. We're going to divide the 5 on this side. So negative 2 divided by 5 equals negative 0.40. Okay, so with this next set of problems, one of the easiest things to do to solve these is cross multiply. So when you have denominators, you want to bring the denominator to the top of the problem. So you want to eliminate the denominator. And in order to eliminate the denominator, you would have to multiply it to get it away. So if you look at here, this side over here, it's really 3 times 7 divided by 2. If we want to move the 2, we would multiply it by 2 on both sides. Same thing over here, 5x divided by 5, we'd have to multiply it by 5 on both sides. Now, doing that multiplication and eliminating the numbers from one side to the next can sometimes get really confusing. So an easier method would be if you see something like this, just do the cross multiplication. So to cross multiply, you would multiply the top times the bottom across from each other. So this new problem becomes 3 times 7 times 5, because we are multiplying 3 times 7 times 5, is equal to 2 times 5x. So 2 times 5x, we've multiplied that across. Now it looks a lot more simple to solve. So we're going to combine the multiplications together. So 3 times 7 times 5 is equal to 105 equals the 2 times 5x. That gives us 10x. So when we divide away the 10, x is left by itself. So that eliminates the 10 over there, and x is then equal to 10.5. Go ahead and pause the video, try to work through the next 2 problems, and then I will help you. Okay, so we have this, which we're going to cross multiply. This becomes, we're going to start up here. So this becomes 4 times x times 2 is equal to, and then we're going to cross multiply the bottom to the top over here, 9 times 10x. And this is actually a typo in the problem, so this was copied over incorrectly. Let me fix this real quick. You pause the video and you're probably really confused right now. So we are going to erase this portion. Boop. And we're going to go back to slideshow. Okay, there we go. This will make a lot more sense. So we have 4 times x times 2, and then we have 9 times the 10. So 4 times x times 2 becomes 2 times 4, which is 8x. And we're going to set that equal to 9 times 10, which is 90. Then we're going to divide away the 8. Divided by 8 to isolate the x. Divided by 8 over here. 90 divided by 8 gives us 11.25. So x is equal to 11.25. Now, the problem that was up there in error before would have given us an inequality, which we don't need to go into when we are working with this class, and that's not something you'd encounter on your qualifying exam. On your qualifying exam, you typically only have one variable that you're going to be solving for at a time, so you won't have those inequality type things. All right, so moving on to this one down here, 6 times 9 times x. Three times 5 times 4. Okay, so now we can do our multiplication. 6 times 9 equals 54 x. And we're going to set that equal to 3 times 5 times 4, 60. Then we want to isolate the x, so we're going to divide away the 54 on both sides. X is equal to 1.11.